Hi, good afternoon, everyone. In today's class, we will go ahead and do all the statistics question of IIT JAM Economics 2022 paper. Now, I will also go ahead and show to you how, you know, IIT has focused a lot on the basics. It has not focused a lot on the intermediate or the advanced stuff. It has been focusing majorly on the basic economics, on the basic statistics. So we will go ahead and we will see why that basic economics is important and why at the end of the day you should be focusing a lot on your formulas. That is what they have been focusing on. So you have to focus on those formulas a lot rather than going ahead and focusing on very, very difficult questions. So take a hint from your 2021 and 22 paper and see what kind of questions IIT is usually asking and try to solve those kind of questions, right? So let's go to the first one. Which of the following correctly defines the relationship between the variances of sample mean for simple random sample drawn with and without a replacement from a normal distribution? This is what the question is asking. Now, to do this question, we must first of all try to differentiate between the 1 second. Okay, so we will go ahead and look at the statistics question in this video, and we will see why it is important to see the formula as well, and we will try to see how IIT has been focusing a lot on the formulas aspect. So to begin with, let us go ahead and look at the first question. This question says, which of the following correctly defines the relationship between variances of sample mean for simple random sample drawn with and without replacement? This is what the question is asking. In order to go ahead and do this question, I would like to first explain you what is with and without replacement. So have a look here. Now, just see here. See, when I talk about variances of sample and I'm talking about with replacement, this is how the sample mean looks. This is the usual formula that we have gone ahead and we have seen. So it is usually that the sample mean, it is normally distributed with mean mu and variance sigma square by n. So with replacement, the sample mean that we have is sigma square by n. Now let's talk about without replacement. When I talk about without replacement, we usually have something which is known as a correction factor, and that is known as finite population correction factor. That finite population correction factor, that is basically given by this n minus n upon n minus n, where capital N is for population and small n is for sample. So remember that whenever I talk about the with replacement part, with replacement, we will have a correction factor, and this correction factor is n minus n upon n minus 1. So in the variance of with replacement, you will go ahead and you will include this correction factor. Okay, so this is how the two will be different. Always remember, this is throughout. One will be without replacement and one will be with replacement. With replacement means what? That, if I have a population and it has different x1, x2, x3 and so on till xn, I want to make a sample out of it. I can choose any one value and then I can choose that again. That is with replacement. That's with replacement. So with replacement is what has the variance sigma square by n, and without replacement, you're going to go ahead and you're going to include this finite population correction factor. Now, there are some notable features that you must want to go ahead and make a note of. First of all, whether I talk about the sample mean with replacement or without replacement, it is always an unbiased estimator of the population mean. So whether I talk about, please make a note, with or without replacement, the sample mean that you find out, this is an unbiased estimator of the population mean. That's the first part. Second part, with replacement, average variance of all possible outcome of sample is sigma square. So ये क्या हो गया? एक बारी देख लो. See, when I say that so I am saying x bar is normally distributed with mean mu and variance sigma square by n. This is the variance of this. Now I want to ask, is this variance an unbiased variance? Is it an unbiased estimator of the variance of the population or not? So the answer is yes. if I find the expected value of sigma square by n, I will simply get sigma square of population. That means that this sigma square by n is an unbiased estimator of the sigma square of the population. So when I talk about with replacement, I am saying that the sigma square by n, the variance that you find for x bar, it is an unbiased estimator of sigma square. Then we talk about what happens without replacement. Now, without replacement, what is the variance that I found out? Without replacement variance was sigma square by n, n minus n by n minus 1. This was without replacement. So I want to ask, is this an unbiased estimator? I'm just giving you all this extra information. You should remember this. Unbiased estimator of sigma square of population. The answer is no. It is an unbiased estimator of a different version of sigma square of population. Which sigma square? When the formula of sigma square is this. So please read this down. Average variance of all possible samples selected without replacement is equal to modified population variance. So the expected value of the variance of the sample which is without replacement, जो भी हमने formula निकाला, it is equal to this. It is equal to the modified population variance. Okay. Now let's go back to question after all this information. So we know that we have got two parts to it. The first part says that we understand that we have the variance of the sample mean with replacement, and that is given by sigma square by n. And we know that without replacement, it is given by sigma square by n, n minus n upon n minus 1. Now we just have to evaluate this factor एक बारी, क्योंकि ये वाला factor तो इससे multiply हुआ है. So what we can do is we can compare. Is n minus n greater than n minus 1? No. N minus n is less than n minus 1 because my sample size will always be greater than 1. So here I am subtracting n from it, and here I am only subtracting 1 from it. So n minus n will be always less than n minus 1. This implies that n minus n upon n minus 1 will be less than 1. So if I multiply sigma square by n on both sides, I will get this relationship number A. So we can say that the correct statement is A. Think about it. Tell me if there is any doubt. So we have got the sigma square of, we have got the variances in the two cases. The sigma square in the first case is sigma square by n, and the sigma square in the second case is sigma square by n into n minus n by n minus 1. And we have been able to prove that this is greater because this factor, this is less than 1. I hope this is clear to you. Okay. Now let's go to the second question. In hypothesis testing, which of the following defines the size of the power of the test? Now just think about it. We have learned two things. One is called type 1 error, and the other is called type 2 error. When I talk about type 1 error, type 1 error is basically alpha. And when I talk about type 2 error is basically beta. We have learned about both of these things. So if I just go back and I have to give you some brief about it, we have to understand that type 1 error is the probability of going ahead and rejecting null when true. And so Shomik, in case of standard deviation, we will just go ahead and take the under root of the variances. So it is just going to be this. Standard deviation will simply be this. Under root of the two things. But make sure that you understand that when I talk about these standard deviations and variances, these are for the mean. Please make sure that this is in your mind. My mean is normally distributed with sample mean is normally distributed with population mean mu and variance sigma square by n. So the standard deviation is sigma by root n in this case. So it's the same here. Sigma by root n, and this will be under root of this thing. Okay, fine. So let's go to this question then. So beta is the probability of accepting null when false. And when I talk about the power of the test is 1 minus beta. So this is the power of the test. So it is 1 minus probability of accepting null when false. Okay, come to the next question. So if you will notice, this question is again asking about with and without replacement. So again, you have to understand that the basic formulas are important from the exam point of view. Okay, so let me just explain you first, and then we will go to the question. Okay, Sudha. So in second question, we are just asking what is type 1 and type 2 error. And from there, we are going about the power of the test. So here, if you notice, type 1 error is called alpha, which is probability of rejecting null when true. And type 2 error is probability of accepting null when false. And power of test is 1 minus beta. So this is going to be this 1 minus probability of accepting null when false. This is your answer. Simply remember, power of the test is 1 minus beta. Okay. Now come to the third question. Suppose that two random samples of size n1 and n2 are selected without replacement. So this is without replacement from two binomial population. This is the mean. So if you remember, the mean is always given by NP. So if it is population 1, then it will be N1 P1 and population 2 will be N2 P2. That is exactly what we have been given. N1 P1 and N2 P2. And the variance is given by NPQ, right? So it will be N1 P1 1 minus P1 and N2 P2 1 minus P2. These are the variances of the binomial population. Now we want to test the hypothesis testing P1 minus P2. So actually you can go to the refer to the notes that I have given you, and that also we have done this. But you know, we have always done with replacement. So with replacement, the formula of sigma 1 square is P1 Q1 by N1. And with replacement, the formula of sigma 2 square is P2 Q2 by N2. Please do not confuse yourself. We are testing proportions, differences. So when we test the difference in proportion, the formula for that, if you remember, if you go back to your notes, you will see it will be P1 minus P2 hat. Hat means population wala. Or you can just put P1 and P2 and then put its expected value. So minus
E of P1 minus E of P2 upon the standard error of P1 plus standard error of P2 under root. And these not standard error of P1, P2 under root, just variance of P1, P2 under root. You can write like that also. So variance of P1 plus variance of P2 under root. You can make it like that also. So basically, this is exactly what we are doing. Usually, this is what your denominator is. Your denominator is under root P1 Q1 by N1 plus under root P2 Q2 by N2. This is what usually we use for differences in the proportion. But because it is with replacement, without replacement, we will go ahead and we will use something which is known as a finite population correction factor. So in finite population correction factor, we will go ahead and we will have this factor. N1 minus N by N1 minus 1, N2 minus N2 by N2 minus 1. These would be my correction factors. Just like we did in the above question. Everywhere you see without replacement versus with replacement, you have to make sure that you include this correction factor. That's the only trick to these questions. So basically, this is exactly what this question is asking, and this is exactly what I have done. So because the question is asking without replacement, I have gone ahead and I have included this correction factor here, population correction factor here. This will be included everywhere. Wherever you do without replacement, this factor will come into picture. So the answer to this question is A. Come to the next question. See how easy questions have been asked in case of probability. Very, very simple questions have been asked. The probability of getting head in toss is 2 by 3. Let the coin be tossed 3 times independently. Then the probability of getting head in first 2 tosses and tail in the final toss is. So it is asking what is head, tail, tail. And these are independent. So it will be probability of head into probability of head into probability of tail. This is head, head, tail. No? So 2 by 3 into 2 by 3 into 1 by 3. So this will be 4 by 27. So very simple question has been asked in probability. Therefore, basics are very, very important. Okay, come to the next question. Which of the following is not correct regarding R square and adjusted R square? So basically what we will go ahead and do is we will go through few of the properties first. I want you to memorize these very well. The first property is the formula of R square. It is ESS by TSS. This formula can also be written as 1 minus RSS by TSS. When I talk about what this means, so basically explained sum of square is the squared deviation of difference between estimated value of y and the mean value of y. So estimated, please do the last 3 lectures very well that I have done, minus mean value of y. And this is the actual value of y minus the mean value of y. So this is the total sum of square, actual minus mean. Now, if you go to lecture 2 notes, in the end, I have written something which is called a scaled version. Okay, I have done something. Lecture 2 money, lecture 2 of the econometrics, if you go there, then I have written something which is called as scaled version of the variables. I just want to explain you here also. So let us go ahead and let us take yi star. And this yi star can be written as w1 into yi. Okay. Now, what have I done? I have taken another variable yi star, and this is the weight that I have given to yi here. Then I have gone ahead and I have taken y bar, mean of y. And I know that if variables scale, then their mean value will also scale. So what you will notice is that the mean of y star will be summation y star by n. But y star is nothing but y1y. So it will be summation w1y by n. You can take this w1 out and it will be summation y by n. So this is simply going to be w1 into y bar. So what you will notice is that if I scale a variable, its mean also scales. This is the property that we have. So therefore, what happens in this case is that this is going to be summation. If I want to find r square for the y star variable, it will be yi star minus y star bar whole square upon summation yi star minus y bar star. And what I have seen here is that this, when I scaled this, when I scaled yi star was w1 yi, then its mean also scaled. So actually in the denominator, I can write this as summation y1 yi minus y1 y bar whole square. And what you can do is, you can go ahead and take this w1 square common. So it will be summation yi minus y bar whole square. ठीक है, ये आपका न्यूमरेटर हो गया, sorry, denominator. On very similar basis, if you solve for the numerator, you will get a very similar analysis, that you will get w1 square summation yi minus y bar, yi hat minus y bar whole square. So actually this w1 square and w1 square will cancel out. So what you will notice is that although I scaled the numerator and denominator, I will share this PDF also with you of the answers, but you will notice that if I scaled the numerator and denominator, my r square did not scale. My r square remained the same only as its previous value, because the amount by which I scaled, it just got cancelled out, right? So basically this is called that r square is invariant in your, it is invariant of scale. It is not affected by scale. But if suppose this year they ask you, what about betas? What about variance? Is it invariant of scale? So I've just shown here that beta 2, this is beta 2 is summation xi yi by summation xi square. So you know, I have just scaled y for now. So is y ki jagah pe I have written yi star minus y bar star. And this is a scaled version. So isko main likh sakti hu w1 yi minus w1 y bar. And this w1 can come out. So I will be left up with summation xi yi by summation xi square. So which means that if I scale yi, then my beta will scale by w1. Beta 2 will scale. So which means that slope that is affected by scale. If you scale your y's, if you suppose each y is multiplied by 10, then the slope, the beta 2 will also be multiplied by 10. This is what this is saying. So slope is affected by scale. This is important. Similarly, in your notes, you will see that I have scaled both w1, both y and x by different factors. So I have scaled y by w1 and I have scaled x by w2. And then you have to go ahead and see what happens to beta 2. So it will come something like this. But you have to go ahead and check as to how the scale changes as you scale both x's and y's. हर एक का scale invariant property पता होना जरूरी है. So in this case, we are saying that r square is not affected by scale. जो पुराना r square आ रहा था और जो नया r square आ रहा है वो same ही है. So therefore it is scale invariant. Now let's go to the properties of r bar square. I have tried to list down all the properties which will be useful to you. सबसे पहले देखो r bar square का जो formula होता है वो ये होता है. So if I try and I open this up, note that if k is 1, then इस k की जगह पे I can just put 1. So I will get n minus 1 divided by n minus 1 if k is 1. Then this factor will be gone. If this factor will be gone, then 1 and 1 will cancel out itself and r bar square will become equal to r square. That means that if the number of parameter is exactly 1, मतलब it's just an intercept model, सिर्फ उस केस में r bar square and r square are equal to each other. Otherwise, what we notice is that r bar square is always less than r square. Always. So this is one of the properties, that adjusted r square is less than the actual r square. The second property that you have is that adjusted r square can also be negative. This is important. Acha. Then the third property is that r bar square may not increase when additional variables are added. Actually, r bar square is supposed to give penalty for adding additional variables. So what will happen? हर बार ये r bar square नहीं बढ़ेगा जब आप एक मॉडल क्रिएट करोगे. So suppose I have yi is equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. Suppose I add one more variable to this model, yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus beta 4 x4i plus ui. Now I'm asking, is this model better, model 1 or model 2? So model 2 will be better only if r bar square has increased. If r bar square has decreased, then model 2 ko mat karna, model 1 will be better. So always when you increase an additional variable, when you go from x2, x3 to x2, x3, x4, you have to check whether r bar square is increasing or not. R square will always increase, always. But r bar square may or may not increase. If it increases, then you have a good model. Then you will go for that bigger model. And when will this increase? देखो ये तो तब increase होगा ना अगर ये जो variable add हुआ it is a good variable. It impacts y. And how do I know if it is a good variable? By testing beta 4. So r bar square will increase only if the additional variable that you have added, in this case I have added x4i, if its corresponding beta 4 when I test its null hypothesis equal to 0 against not equal to 0, when I do a t-test on it, if t-test is able to reject null, please make note of all this. So if I test this individually, how important this variable is, and if I am able to prove that, this variable individually is in fact important, if I am able to reject null in favor of alternative, it means this variable is important. If this variable is important, then I will go ahead and I will see that uska corresponding r bar square bhi increase ho gaya. So actually, to give you an example, suppose I make next model, yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus beta 4 x4i plus ui. Suppose iska r bar square has decreased as compared to this model, not this, let's include x5i also, then it will make sense. So plus beta 5x5i plus ui. Suppose the r bar square has decreased as compared to the earlier model, r bar square has decreased. इसका क्या मतलब है? डिक्रीज होने का मतलब ये है कि ये जो नेक्स्ट वेरिएबल मैंने ऐड किया है ये किसी भी यूज का नहीं था, इट्स अ यूजलेस वेरिएबल. That means if I would have done only a t-test on this variable's slope, I would have got that t-test is useless. This is what I would have got, that I would have been not able to reject null. Are you getting it? So that is why its r bar square would have decreased. So this is what is about r bar square. In case of r bar square, you have to note that it can be negative. It can decrease when you add an additional variable. It is less than r square. And this is the formula for r bar square. So you just remember this formula also, please. Then next come to r square. R square will always increase. Whenever you add a variable, r square will always increase. What was r square? It was telling how you are explaining jointly the variation in y due to x's. So r square का formula होता है, so r square definition is how jointly x's explain y. So if you increase x's, the joint explanation on y will always increase. But because r bar square has this penalty term, it has this it is, you know, including the degrees of freedom, it is giving penalty for increasing the variables. यहाँ पे minus k हो रहा है, k is the number of parameters. It gives penalty for that. So therefore, because it gives penalty for adding additional variable, r bar square will not always increase. Please make sure you understand each and every point related to r square and r bar square. So on the basis of that, we will say r square is scale invariant, correct. It is always r bar square always positive, incorrect. R square tends to increase if additional variable is added, correct. This is the formula of r bar square, correct. So these are all accordingly. Okay, come to the next question. It says x is normally distributed and y is also normally distributed. Which of the following is not correct? देखो normally distributed है. So if I come to the normal distribution formula, then this is the probability distribution of a normal distribution. This is how it looks. You should remember this much. This is the probability density function of a normal distribution. Now for this probability density function, actually what happens is the area under the curve is actually 1, right? But this density function, it is defined from minus infinity to infinity. And ये जो बीच वाला value होता है, this is at mean. So it is mean equal to median equal to mode. And the total area under the curve, क्योंकि probability distribution है ना, so the area under the curve will be 1. But this area under the curve is from minus infinity to infinity. That is 1. If I just find the area from mean to infinity, so ये तो 0.5 होगा, right? Because I'm just taking this part. It will not be 1. So if I just take from mean to infinity, the area should be 0.5. But if I take from minus infinity to infinity, area should be 1. So on that basis, if you just come back to this question, the first question is saying that I'm integrating probability density function, no problem. But the question is integrating from minus infinity to mu x, from minus infinity to mean. Mane it is integrating like this, minus infinity to mean. So it is actually finding this area. And this area is not 1. So this is incorrect statement. Okay, now come to the second part. So now it is asking about, this is something I have taught you. Theory बहुत important है. यही theory we have done in class. So it asks about the area under the normal probability curve. And we know that we have 68%, 95% and 99% based on 1 standard deviation, 2 standard deviation and 3 standard deviation. This is how much area we cover. Now it says that the area under normal probability curve between ordinates is mu plus minus 3 standard deviation. So 3 standard deviation के अंदर कितना था? 99%. But this is saying 95%. So this is incorrect. And then it is saying plus minus 2 standard deviation में 99. This is also incorrect. Plus minus 2 standard deviation, it should be 99. So they have actually reversed these values, right? So therefore, this is an incorrect option because the values have been reversed. So please make a note. Values have been reversed. This will be mu plus minus 2 standard deviation, mu plus minus 3 standard deviation, mu plus minus standard deviation. इसको यहाँ पर भी दिखा सकते हैं Z में. So if this is mu, then this is 1 standard deviation के gap में, mu minus standard deviation, mu plus standard deviation. This area is 68%. Then if I add mu minus 2 standard deviation, mu plus 2 standard deviation, this area is 95%. and the remaining is 99%. These are the properties, okay? Okay, quartile deviation to mean absolute deviation to standard deviation. Again, this is a given property. It is 2/3 is to 4/5 is to sigma. This is correct. And please make note of all these properties. If X and Y are independent, then this is the normal distribution. I just want to give one thing here. So when I talk about variance of X minus Y, we did this in the very basic chapter of variances. Minus sign se farak nahi padta hai. It is going to be variance of X plus variance of Y. Minus sign se farak padta agar hum covariance nikal rahe hote. So this will be minus covariance X, Y. But they are not related to each other. They're independent. So the covariance will be 0. So as far as the variance is concerned, it will always be a plus sign. How can you remember this? Remember this formula. A minus B whole square is A square plus B square minus 2AB. So A square or B square में plus sign ही आता है always. These are the variances. इनके बीच में हमेशा you will have a plus sign. So if you notice here, this has a plus sign between the variances. Mean has a minus sign. This is absolutely correct. So X minus Y is normally distributed with mean getting subtracted, but variance will always be added. Okay. Now come to the next question. So it says, suppose that regression model is given by this, which of the following null hypothesis could be tested using F-test? Again, I have just given you a note of this. Please read through it. I will post this in your portal also so that you have it with you. So F-test can be used in the following cases. F-test is always used to check the joint effect of Y. Y jointly kitna affect ho raha hai X's se. So it is always a joint effect, right? So F-test is used to understand how Y is getting jointly affected by X's. And the null hypothesis in this case is beta 1 equal to beta 2 equal to 0. You are setting both equal to 0 together. An alternative is that one of them is not 0. One of them not 0. This is your null versus alternative. So we always use F-test to do a joint test, whether both the betas together are 0 or not. Because we are checking a joint test of the betas, therefore it is equivalent to testing whether your R square itself is 0 or not, right? And as I have showed you in our lectures, it is also used to test restricted versus unrestricted model. What is a restricted model? A restricted model is one where some of the parameters are left. Some of the parameters are left. And unrestricted is with full parameters. And I have given you formula for this also. So just read that. So we have seen that suppose I have a model which looks something like this. Null chodo. Suppose I have a model yi equal to beta 1 plus beta 2 x2y plus ui. And suppose I have another model yi equal to beta 1 plus beta 2 x2y plus beta 3 x3i plus beta 4 x4i plus ui. Suppose I have these two models. Then this will be called my restricted model because it has restricted parameters. It only has beta 1 and beta 2. And this will be my unrestricted model because it has all the parameters, beta 1, beta 2, beta 3 and beta 4. So checking which model is better, restricted or unrestricted, then also you will use F-test. For formula, refer back to our lecture. This can use F-test, this can use F-test. Finally, sometimes I want to check whether my intercept model is better. तो मतलब क्या होगा? इस केस में मेरा जो restricted model होगा, it will be just this, without any variable. Just for example, I can say that rainfall does not depend on anything. It is this much meter. It is this much quantity. So I have given some value of rainfall, but I am saying it does not depend on anything. Another model says that rainfall depends. on precipitation, on maybe, you know, due amount, on 10 things, on location. So what we are doing is this becomes my unrestricted model and this becomes restricted. This is an intercept only model. Then also I can use the F test. So these are the places where an F test can be used. Based on that, we are using F test in this case, and we are using in the intercept only model. So I can use it in B also. Okay. Now come to the next question. Actually, this question should not have been given, according to my opinion. The reason is that this is what is done in DSC in the third semester. This is a difficult question and it's an MA level question. I mean, we used to do it with our faculty called, her name was JVM, right? JV Meenakshi, and she used to do it in the third semester of Delhi School of Economics. It's a difficult thing to do. However, what I see in the answer sheet is that they have given marks to every individual. But because they have given it to you, I will just give you some formulations of this question also, so that in case it comes, you should know what to do. So this is the model given to you. You're given some betas. You're given X transpose X inverse and X transpose Y. And you're given E transpose E also. So just have a look here. The aim that they're asking to check is whether beta 3 is 0 or not. So my null hypothesis is that beta 3 is 0 and my alternative hypothesis is beta 3 is not equal to 0. ये तो same है. T value भी वैसे ही निकालिए जैसे we find out. So my T value is beta 3 hat minus beta 3 upon standard error of beta 3. So this is going to be beta 3 hat minus beta 3 I will pick from my null hypothesis. So 0 upon standard error of beta 3 hat. So this is going to be beta 3 hat upon standard error of beta 3 hat. Okay. So two things I want to find out. I want to find out what is beta 3 hat and what is standard error of beta 3 hat. Now, usually whenever we have a matrix form of econometrics, this is how we write this model. So I have different y's. This y is n cross 1. I have different x's. The x's are n cross p. Different betas. There are p parameters. P betas. So it is p cross 1. And then I have different e's, different errors, which is n cross 1. Now think about the matrix multiplication. Suppose I have n errors and I have p cross 1 matrix of the parameters. तो इसको क्या होना पड़ेगा so that you get this multiplied? N cross p, because I want this to be of n cross 1. Then only I can add it to n cross 1. And अगर इसको n cross 1 होना है and this is p cross 1, then this must be n cross p. So this will be n cross p. What does this mean? It means that पहला तो हो जाएगा 1, because if I multiply 1 with beta naught, I will get this beta naught. Then the other one will be x11. If I multiply x11 with beta 1, I will get beta 1 x11. Then this will be multiplied with beta 2, I will get the next. Then this will be multiplied with beta p, I will get this. And then I will add E1 to it and I will get this, and this will be equal to the first value Y1 and so on. This is how your matrix would be formed. So the matrix will be looking like this. Y is equal to x beta plus epsilon. Now, usually क्या aim था हमारा OLS regression का? Aim was to minimize summation EI square, है ना? But this is a matrix. So matrix को अगर मुझे summation EI square लिखना है, it means that this error term, it must be multiplied to itself and then summed up. तो actually इसको लिखने का तरीका यहाँ पर ये हो जाता है E transpose E. This is how you can go ahead and write it. And aim क्या था? To minimize residual sum of square. So when you will minimize E transpose E, you will get actually this. So किसके respect में हम इसको minimize कर रहे थे? We were minimizing these with respect to betas, right? And then when we solved these equations, we were getting betas. And if you remember, in a two variable model, my beta was summation xi yi upon summation xi square. So this is nothing but x into y summed up into summation xi square inverse. Agar मैं इसको एक साथ लिखूं, so exactly same, something like that you will get here. X transpose x inverse into x transpose y. This is the value of beta when you will minimize the residual sum of square. So on minimizing residual sum of square, the betas that you get is nothing but x transpose x inverse into x transpose y. Ye wala matrix is given to me. I am given this in the question. I am given this also in the question. So if I'm given x transpose x inverse and if I'm given x transpose y, I can just multiply the two and I will get this. So after multiplying, I get this as the answer. Just have a look here. You will get a matrix which is of the form 3 cross 1. Isme the first value will be beta 1 hat, beta 2 hat and third will be beta 3 hat. So actually speaking, यहाँ पर जो आपका t value था ना, जो हम t निकाल रहे थे, इसका numerator we have found out. This beta 3 hat, this I have found out as this 0.25. Now we want to talk about the variance of beta. So actually, again, if you go back to your two variable regression and you check your variance, it was sigma square upon summation xi square. Ye variance tha. Just go back and check. That was the variance of beta 2 in a two variable model. So exactly something like this is this. This is the variance of beta, sigma square x transpose x inverse. But do you remember that when this was not available, so instead of sigma square, you were using sigma hat square, and sigma hat square was summation ei square upon n minus k, where k was the number of parameters. ये इसका formula था. तो इसी तरीके से हम यहाँ पे भी लिख सकते हैं. Summation ei square को हम लिख लेंगे e transpose e upon n minus k. So e transpose e, this is 0.7 given to us. N is given to us as 20. This is 20 and number of parameters are 3. So 20 minus 3 will be not 20. This is given to us as 23, sorry. So 23 minus 3 is going to be 20. So my denominator will become 20 and this will be sigma hat square. So I have got sigma hat square, matlab ye wala value. Sigma and x transpose x inverse, this is given to me. So I can find variance of beta also. So this is exactly what I have done. Now when you will multiply, you will actually get this matrix. This matrix, it is called the variance covariance matrix. This matrix is called variance covariance matrix. ये होता है variance of beta 1 hat, variance of beta 2 hat, variance of beta 3 hat, और एक्चुअली बाकी वैल्यूज कोवेरियंस होती है. अब यहां पर इन्होंने वैल्यूज गलत दी है बिकॉज कोवेरियंस शुड मीट. जो वैल्यू यहां आ रही है एग्जैक्टली सेम वैल्यू यहां आनी चाहिए. दीज आर कोवेरियंस. सो वेदर आई फाइंड कोवेरियंस बिटवीन बीटा 1 बीटा 2 और कोवेरियंस बिटवीन बीटा 2 बीटा 1, I should get the same answer, but that is not happening. Maybe that is why they thought the question is wrong and they gave marks to all. But anyways, so if I just check, these are covariance. यहाँ पे beta 1 लिखो, beta 2 लिखो, beta 3, beta 1, beta 2, beta 3. So this covariance between beta 3 and beta 3 is variance of beta 3. This is variance of beta 1, variance of beta 2, and so on. So I am interested in this value. So I just pick up on this value, and to find standard error, I just make an under root of it. So when I do an under root of this, I get 0.1024. Standard error mil gaya, beta 3 mil gaya hai. Just find this value. It will be 2.44. So the value of t statistic will be 2.44. Still, I am telling you, this is too much over the head. This is not something an undergraduate student is supposed to know. But you can go, isse upar to kahin nahi aa sakta. So you can go through this question to have a look at the kind of question that can come in exam. So over and above what we see that actually speaking, the paper is pretty simple, based mostly on theory questions of probability distribution, theory of normal distribution, theory of with and without replacement formulas. So you have to look at the assumptions very well, at the formulas very well. You have to understand each and every aspect of what is a probability density function. How do you go ahead and you understand that this is probability density function of binomial, of geometric? What are the properties of hypothesis testing? Difference in proportion का hypothesis testing क्या है? Difference in mean का hypothesis testing क्या है? To test difference of variances, what is the hypothesis testing? When to use F-test? When to use the other tests? You have to be very, very clear with that. I will give you some more important questions on statistics in the coming week, from next Monday to Friday, which I think can come especially from the theory part, because we have to be very, very, very particular about theory. But other than that, in your portal, you will find all solutions to 2021 paper. And you're supposed to go ahead and do those also. Ye na ho ki 2021 ko you skip. So proportion is usually binomial. Just say if in question it is given that 36 out of 50 people cleared the test. So 36 by 50 is my proportion. So if you are testing for binomial distributions, जैसे अगर normal होता that on an average group A's IQ is 40, group B's IQ is 50, is there any difference in their IQ? Then it is difference in mean. But if I ask you group A 36 out of 50 people cleared the test, group B 38 out of 50 people cleared the test, is there any difference in their proportion? Then that's a proportion test. That's it. Okay. Is movement generating function going to be asked in IIT? It is in syllabus. So if it is in syllabus, I cannot negate it. That is why I have included a video in the intermediate lectures. But it hasn't been asked in the last 2 years. But I would suggest have a look at it. Don't skip it completely. एक बारी बस उस video को देख लो. Don't skip it. Okay. Anything else? Any other question based on statistics? Yes, if you see F-test came for 2 marks in the last paper. So there is no reason to skip F-test. Please don't skip it. Yes, please know all the formulas of distribution. Don't skip a single formula. That is why I just covered single distribution on one day. You have to know the formulas. Distribution, just for example, Poisson may e to the power minus lambda, lambda to the power x by x factorial. You should know all of that. Yes, so ideally chi-square is not particularly important, but I can refer to you a video from the intermediate lectures which talks about that. I was planning to do 2 to 3 questions on chi-square on Monday and give that to you. So I will give whatever question I think is important based on that. More than that, more than what question I will give on chi-square, don't do that. But go through the notes well on hypothesis testing. Jitna bhi usme kiya hai, that is important. You have to know each and every line of that note. Okay. Anything else from statistics? Yes.
Ma'am, when should the questions be available in the question bank, ma'am, for statistics?
Yeah, Monday onwards. I'm just finishing off our mock tests by Sunday. Then we will focus on the mock on the question bank of stats.
मैम
Okay, ma'am.
मैम
Yes.
मैम आपने जो एफ टेस्ट जहाँ से नोट से करवाया तो वो अपलोड कर दिया आपने, क्योंकि मैंने देखा था वहाँ पे अपलोड वो दिया हुआ नहीं होता.
The notes?
Yes, ma'am.
Let me check. Can you just put it in the group once so that I don't forget? Okay.
Okay, ma'am.
Just
Okay.
just post that the notes of F test have to be posted. I will check. Okay.
Okay, मैम.
Anything else?
मैम एक और चीज पूछना है आपसे मैम.
Yes.
एफ टेस्ट में जहां तक आपने नोट्स में कराया वहीं तक करना है ना, और एक्स्ट्रा
Yes.
कुछ डिफिकल्ट
कुछ
क्वेश्चंस
नहीं,
नहीं करना है?
कुछ नहीं. You should know that F distribution is skewed. You should know that the variance of higher comes in the numerator. You should know the degrees of freedom of numerator and denominator. And then जो मैंने econometrics में F test का use बताया है, you have to know that also. It is available in multiple linear regression model. So the last lecture of advanced statistics, उसमें भी F test use हुआ है. You should know that also.
ओके मैम.
Okay. Anything else?
मैम कोरिलेशन कोफिशिएंट उसको भी करना पड़ेगा?
Rank correlation and all is not important. Correlation coefficient is only important from hypothesis testing point of view. So we have covered R square for 2 variable and multiple. That's enough.
Okay, ma'am.
And ma'am, for Indian Eco?
Indian Eco is vast. You can go through all the lectures that I have given you. And if you notice, some tests have been uploaded in Indian Eco. Try to go through those tests. They're based on all 5-year plans, and they're based on the planning commission, and they're based on the other aspects of inequality. But other than that, in Indian Eco, जो fixed चीजें हैं वो जरूर कर लेना. So go through what is your HDI, Human Development Index. उसका formula क्या है? It's there in the notes. If you go to the in the videos, go through all the poverty index. Go through all the inequality index, like what is Gini coefficient, what is Lorentz curve. It's there in the videos. So the things that we know for sure, जो indices आ सकते हैं, go through those. Go through the 1991 policies. It's there in the videos. Go through the policies of 5-year plan. It's there in the videos. Fixed cheeze you can do, but otherwise, if you notice, last year they asked about amendment. Nobody can expect कि amendment के बारे में पूछेंगे. So it's vast. If you have time, do the tests. Otherwise, I would say out of 8 questions, at least 2 से 3 questions will be on the indices, will be on the 1991 policy, will be on the 5-year plans. Make sure you know those questions well. So just do those indices. And her index pay question has been added in the mock test. So make sure that you do the mock tests well. I have tried to add whatever relevant questions are there in mock test also, but it is uncertain. I cannot say that, what we do is enough for Indian Eco. It will never be. It's vast.
Ma'am?
Yes.
Ma'am, micro में moral hazard आ सकता है क्या उसका numericals?
किसके ऊपर?
Moral hazard.
Moral hazard पे it has not been asked yet, but yes, at least do what we have done. Do a question on signaling, not more than that.
Okay, ma'am.
I don't think at least in micro or macro or stats, you will see anything which is beyond what I have covered. It will never happen. In fact, last year, few of my students only did intermediate videos, and he had a rank of 13 all India in IIT. You will not get beyond what we have covered. You have to be very thorough with what we have covered. Make revision notes, cover those notes, go through each and every formula, and use presence of mind. Kabhi question easy hota hai, you keep thinking it the difficult way. Just for example, in the question that I showed you today on normal distribution, people got so confused ki mu x, mu y, ab kya hoga? And it was a basic question asking about the area under the curve, which should be 1, and it was given for 50%, they had given 1. So basic questions mein you should know presence of mind. Just don't get so much worried by looking at these simps, these symbols ki itna sara mu x, mu y, ye sab kya hai? Question is pretty simple. So they are going to test the basics. बहुत difficult paper नहीं होगा, but they will change, इधर उधर language थोड़ा change करके करेंगे. जैसे for example, I showed you, right? 99% वाला area 2 sigma में दिया हुआ था, 2 sigma में, and 95% वाला 3 sigma में. They just reverted the values. Now, if you don't read carefully, you will think what is wrong with this statement. So presence of mind is important. Going through the question in detail is important. And revising whatever we have done is important. Please don't go over and beyond this. At this point, no one should be doing ISI or DSE paper. It is not going to come. Itna mushkil paper nahi hota hai. ISI is another level. Don't focus till 12th of Feb on ISI, please. Gamma, no, not very important.
मैम एक बात पूछ रहे हैं ऐसे ही जनरली, मैम हम लोग के मॉक से इजी होगा या फिर मॉक से थोड़ा डिफिकल्ट होगा?
Comparatively easier. The last 2-3 mocks ka barabar ka hoga. First 2-3 mocks were difficult, but I had to cover some topics in those. It's going to be according to the last few mock papers. But make sure you do each and every question of those mock papers.
Okay, ma'am.
Okay, thank you.